Hello, and welcome to the video for section 7.2, graphing rational functions. So we're going to start off by defining a rational function. A rational function has the form f of x equals a function over another function, where p and q are polynomials and q cannot equal 0. Remember, if q of x equals 0, then it's undefined and it doesn't work. So our simple basic parent function for a rational function is 1 over x. All right, we'll notice that this is now going to be a shape called a hyperbola, all right, that contains two symmetrical parts called branches, and the domain and range are all non-zero real numbers. The reason the domain and range are all non-zero real numbers is because we never get a 0 for an x or a 0 for a y. All right, so we look at it, it's hard to see here, but I'm going to say that the vertical asymptote, and if you guys have highlighters, it'll definitely be helpful, is the line x equals 0. So notice here, when we talked about asymptotes, a lot of them been horizontal, and with logs, they're vertical. It's the same thing here. This one, though, has a vertical and a horizontal asymptote. So when we look at these, here's our two asymptotes that I'm going to use colors to help us realize which one's which. All right, so we're going to go, and now we're going to graph our first rational function. Our first rational function is 4 over x. So when we do this, our vertical asymptote will be x equals 0. And a way we can get that is by just setting the denominator equal to 0. All right, that's a value we cannot get. There's no plus or minus after this, so our horizontal asymptote will also be 0. All right, when we go through and do this, I'm going to make a note and tell you that what we should do is you should pick at least 3 points to the right and left of the vertical asymptote. All right, and I always am going to simplify it by writing VA for vertical asymptote. So when I do this, I set up my table. All right, this line here is going to be my vertical asymptote, which in this case is x equals 0. 3 points to the right would be 1, 2, and 3. 3 points to the left would be -1, -2, and -3. All right, so as I go through, I'm going to pick these points, plug them into the equation. 4 over 1 is 4, 4 over 2 is 2, and 4 over 3 is 1.3 repeating. If I then plugged in -1, that's -4, -2 would be -2, and -1.3 repeating. All right, so those numbers should look pretty symmetrical. You can also plug those into your calculator to get those values. So to graph this, I'm going to start off by highlighting my two asymptotes. All right, so x equals 0 is my vertical asymptote, and y equals 0 is my horizontal asymptote. All right, so now what I'm going to do is I'm going to plot my points, 1, 4, 2, 2, and 1.3 repeating. Now we know they're going to approach both of the asymptotes, so we can kind of draw in our lines as we go. If I plugged in -1, -4, -2, -2, -2, -1/3, we can kind of see our graphs here. Okay, these are enough points to be able to graph these. Notice both of the branches approach the asymptotes as we go towards infinities, and that's what you have for the first one. Now, they're not all going to be in the simplest form. So if we look at here, we're going to translate these. Now, these h and k should look pretty familiar for you. Remember, an h is going to move this horizontally, left and right, opposite direction of the sign, and the k is going to move this up and down. So it goes through, gives us some steps to graph these. We're going to draw the asymptotes, x equals h and y equals k, plot 3 points to the left and right of the vertical asymptote, and then we're going to draw the branches, so we have our graph. All right, so when we look at this here, we're going to go through, and I want to go through the same thing like we did with the previous one. Our vertical asymptote, it's not moved left or right, so it will be x equals 0. Our horizontal asymptote will come from this -2, so now this will be y equals -2. So when I go through, I set up my table, I draw my vertical asymptote, which is x equals 0, and pick points to the right and left of that, which is 1, 2, and 3, -1, -2, and -3. All right, those values, when we plug them in, will be 1 for 1, 2 will be -0.5, and 3 will be -1. -1 will be -5, -3.5, and -3. So once again, to graph these, it's the same way. We're going to start off by graphing our vertical asymptote, which is x equals 0. And then we're going to graph our horizontal asymptote, which is y equals -2. So we're going to move it down 2 here. And now we're going to plot our points. We're going to plot 1, 1, 2, -0.5, 3, -1. And we know this is going to approach both branches. So we have our branch to the right, and now when we plot -1, -5, 1, 2, 3, 4, 5, -3.5, -3, we have our branch this way. All right. The only other thing they asked was the domain and range and interval notation. Well, our domain cannot be 0, all right? It basically comes from our asymptote. So it'll be from -infinity to 0, union 0 to infinity. So if we notice, whatever value our vertical asymptote is, that's the value that goes in our interval notation. For our range, it's whatever our y cannot equal, which is -2. So we'd say -infinity to -2, parentheses, -2 to infinity. Because -2 is the only value that we cannot have for our y values. All right? So let's graph another one of these, all right, that looks a little bit different, all right, and it kind of moves it both horizontally and vertically. Now, if we think about this here, it says x minus 1. So our vertical asymptote will now be x equals 1. Our horizontal asymptote is our plus 3, so that'll be y equals 3. So we set up our table, just like we normally would. Put our squiggly line, which is our vertical asymptote at x equals 1. 3 points to the right would be 2, 3, and 4. And 3 points to the left would be 0, -1, -2. So we're going to graph our asymptotes, which is x equals 1. All right. And our horizontal asymptote, which is y equals 3. All right, so we have our asymptotes. When we go to plug this in, we will get 2, 1, 3, 2, 4, 2.3 repeating. 0 will be 5, -1 will be 4, and -2 will be 3.6 repeating. I will say when you go to put this in your calculator, make sure that the denominator is in parentheses when you type it in, because your calculator is programmed to do orders of operation the correct way, so it's important how we plug this in. We go through to plot the points now. 2, 1, 3, 2, 2.3 repeating. We draw our branch here. 0, 5, 1, 2, 3, 4, 5, 4, 3.6 repeating. All right, now notice our branches are in different, sections of our graph, and that's because of this negative here, which would reflect it over the x-axis, so that's why they're now in those sections. Okay. All right, to progress with a little bit different here for graphing other rational functions, some of them will have an x in both the numerator and denominator. All right, so when we go, I'm sorry, I forgot, let me go back to this one. I forgot the domain and range. The domain of this function would be -infinity to 1, union 1 to infinity, and our range would be -infinity to, you got it, 3, union 3 to infinity. Remember, This comes from our vertical asymptote in our domain, and our range comes from our horizontal asymptote. Okay? All right. So going back to the other rational functions, we want them to have both an x in the numerator and denominator here. And when we do this now, we notice the vertical asymptote is going to be x equals negative d over c. Basically, set the denominator equal to 0 and solve for x. All right, for our horizontal asymptote, it's the coefficients of our x's. All right, so let's talk with the first one here. All right, so it says identify the horizontal and vertical asymptotes. So the vertical asymptote, to get that, we would set the denominator equal to 0. So our vertical asymptote is negative 2. Our horizontal asymptote will come from the coefficients of our x, which is 3 over 1. So our horizontal asymptote is 3. All right. I'm only going to do the domain and range for this one because we're going to do the next couple. Remember, negative infinity. Where's our vertical asymptote? Negative 2. Negative 2 to infinity. And the range would be negative infinity to 3, union 3 to infinity. Notice where these things come from. Our asymptotes. Okay. All right, for example, B, same thing. To get the vertical asymptote, we set the denominator equal to 0, which gives us 1. To get our horizontal asymptote would be y equals 2 over 1, which would be y equals 2. So there's our two horizontal and vertical asymptotes, the domain and range. I'm not worried about this one because we'll practice some more on the next page. All right, last example. All right, so what we're going to do is we're going to graph the following, state the horizontal and vertical asymptotes and the domain and range. So now notice we have a variable in both the numerator and denominator. So to get our vertical asymptote, we would say x plus 2 equals 0. So our vertical asymptote is negative 2. For our horizontal asymptote, we would take the coefficients of our x's, which would be 3 over 1. So that would be 3. Once we get our horizontal and vertical asymptotes in this form, the steps for graphing are the exact same. We set up our table. Here is our vertical asymptote of x equals negative 2. 3 points to the right would be negative 1, 0, and 1. 3 points to the left would be negative 3, negative 4, and negative 5. All right, my suggestion would be to get these y values, is plug them into your calculator. Make sure you put both the numerator and denominator in parentheses for the orders of operation. When we go through and get these values, negative 1 would be negative 4, 0 would be negative 0.5, and 1 would be 0.6 repeating. Our y values for negative 3 would be 10, for negative 4 would be 6.5, and for negative 5 it would be 5.3 repeating. So we go to graph them now. We're going to draw in our vertical asymptote here at negative 2. All right. We're now going to draw in our horizontal asymptote at y equals 3. And then we're going to plot our branches like we would and connect them. So negative 1, negative 4. 1, 2, 3, 4. 0, negative 0.5. 1, 0.6. And we know it's going to approach these asymptotes, so we just kind of want to draw them and not really have them touch. So we have that one there. We have negative 3, 10. Negative 4. 6.5, 5 1/3. So we're going to draw it up here like so, and it's going to approach to the left. The only other thing we need to do here is the domain is negative infinity to negative 2, union negative 2 to infinity, and our range is our horizontal asymptote, negative infinity to 3, union 3 to infinity. Okay, once again, I'll highlight these with the same color so we can see the connection, hopefully. All right, so it is a new concept. We haven't really seen rational functions. All right, so we got to practice those, and also we get a little practice of domain and range and interval notation. If you have any questions, please let us know. Your homework will be posted soon. Have a great day.